Okay, is on this encoder here. As we know that, okay, this encoder and decoder, okay, they are actually just inverse lah. So you're going to find that, okay, so encoder here will provide the conversions of binary info in one form or another. So encoder will have more input than output. Okay, they have more input than output. Okay, more input than the output. So of course, okay, the simplest one is a 2n to n. So this is now the output number. Okay, output number. So this input is the 2 to a power of the output number. All right. So this part here, let's look at the truth table here. So you're going to find that, okay, my this encoder here, let me make it smaller a bit. This encoder here, input is 8 bit and output only 3 bits. So let's say, okay, out of these 3 bits here, you see only ZO is a 1 that indicate that my input is actually the X1. So they encode this input. All right, they encode this input 4. So combinations of this one here now show me is a 4. Okay, output combinations show me this is a 7 because they encode that input is a X7. All right, so this is encoder. So very easy, okay, if we want to design this encoder here. So what we do here is Z1, we go and write down, okay, Z1, how to make this Z2 here equals to a 1. How to make Z2 equals to 1? You find that there are 4 ones, okay, appear at this Z2 here. So Z2 will be a 1 if my X4 is a 1, or X5, or X6, or X7. So the word here all means that now write it in terms of max, okay, it will look like something like plus all them together. So we all these are input together, that will forms my Z2. Do the same thing for Z1 and Z0. All right, same type of concept. So with that, okay, if we want to know the internal architecture of it, okay, very easy also. So your inputs here. All right, you take whatever input that you want based on the equation that we have just now, and you find that, okay, XO in this case here, the XO input, okay, is not being used to any of these OR gates over here, but we have to put this thing in, just that is something like, okay, we press the number 0, so we have to press it. All right, then you find that, okay, here will code me 0, 0, 0, because not being picked up by any one of these. All right, so the output will show me 0, 0, 0. All right, so this is the internal architecture, and no symbol, input, output. Okay, now you may find that, okay, this encoder here, what's so special about it? Okay, so think about your keypad. Okay, my keypad here may have, okay, small digit. Okay, wow, my drawing is no good. Okay, so say like, I don't know, number 1, number 2, number 3, 1, 2. Okay, so let's say 3, 4, 5, things like that. Okay, so sometimes, okay, when we press this number that time accidentally, or maybe the keypad here too small, so when we press, okay, let's say I want to press 1, but accidentally, okay, I press both of them. Okay, I press both of them at the same time. So in this case here, the systems, okay, of this keypad here will decide, should I show you 1 or should I show you 4? Okay, that comes, okay, this thing here called priority encoder. In priority encoder, if more than one input is being asserted, you think about it, it's pressing, selected at any one time. In order to show an appropriate output, you need to use a priority encoder. So there are actually different types of priority encoder. One here is if you press 2 number, okay, they will show you the largest number. Say for example here, still, okay, 8 input, 3 outputs. In this case here, we add in this one, something like our enable. Okay, my enable here must be a 1. Then only it will work. If it's 0, you find that forever 0. Okay, forever 0. All right, so we assume, okay, now our enable is a 1 here. And now here, don't care terms, like I told you all earlier, don't care in this case here means a 0 or 1. So maybe accidentally I press 2 number. Okay, I press 2 number, 0 and 1 at the same time. For this priority encoder here, we will take, okay, show us the higher number. Okay, higher number, this is my number, then higher priority. We are the one who decide for it. Okay, higher number having higher priority. So if I press these 2 numbers at the same time, the output will show me 1. Okay, if I press, for example, 1, 2, 3, 4, 5, 5 numbers, okay, using my palm, okay, I press all these 5 numbers at the same time. All right, X4 is the highest number compared to X3 up and here. Then you find that, okay, the output that I'm going to set is show me the 4. All right, press everything. Then they are going to show me the 7 because 7 is the higher number or highest number in this case. Okay, so this type of priority, this priority encoder here is based on this concept: high number, high priority. All right. Okay, so come to design. Okay, how are we going to design it? Okay, we'll look at it afterwards. Okay, then you are going to find that, okay, the other way around, we can have this. Okay, now this is a lower number. Okay, you got high priority. So if I press 2 number, okay, if I press 2 number, 1 and 2 at the same time, then they are going to show me the lower number, which is 1 that they are going to show me. So in order for them to show me the 1, you must make sure that you don't press 0, because once you press 0 here, they are going to show you the 0 here. You see? When I press 0 and all other digits, all the digits, then they show me the smallest number or the lowest number, which is 0 in this case. For me to show 7 at the output, I must make sure carefully, don't simply press anyone except the 7. Then they will show me 7. So this type of priority encoder here is they show you lower number. Okay, whichever number comes in, I don't care. I only show you the lowest number. All right. So with this here, how we are going to do the design. So you are going to find that this part here is a bit scary, right? There are so many number of them. Actually, how do they do it? Okay, so in this case here, I need a blank paper because I need to see this one and show you. Okay, let me get a piece of blank paper. Now, based on this table here, you find that, okay, we need to work out the Z2. For example, for the case of Z2, of course, I still see 4 ones over here. But because of this, don't care here. Okay, so I cannot just say that, okay, I only consider, okay, X4 plus X5 plus X6 and so on. Cannot. So you must sort of, okay, ensure that, okay, for my Z2 to turn on, I must ensure that, okay, these are all 0. So my X0, X1, X2, X3 are all 0. Then my X4 only is a 1. Okay. Subsequently, Same thing for the second one, for the x5. Okay, x5 only is a 1. Continue. So you find that, okay, there are a lot of common, okay, input variables over here. You might later on, okay, go and simplify them. And we are going to apply, okay, Boolean algebra to it. Okay, x4, x5, okay, and we got my x6. Okay, one more. So I show 1, 2, 3, 4, 5, okay, 6, 7. Okay, so these are the expressions, okay, for your Z2. Okay, so like I say, okay, you have a lot of common variables in this case here. I may want to simplify them. Of course, first one, okay, you find that these are all the while common. So we take it out. And here you are going to get your x4 plus 4 plus 5 plus this is 4, 5, then 6. 4, 5, 6, 7. Okay, now not sure whether you still remember one of the Boolean algebra here say that a plus a plus a bar b, okay, eventually is the same as a plus b. Okay, how I can get this a plus b here? This is because, okay, with this one here, I can always take my a, confirm that this is correct. Okay, confirm that this is correct. So from this part here, a, I go and times it with 1 plus, okay, I saw this is b, right? A bar don't see, always, okay, this one here are complements of it. So I see the b, so I 1 plus b. Okay, then plus back the a bar b. I'm doing this one. Okay, I add in this on my own. So once I add this one, I go and expand this one. Okay, so don't touch this one, A. And now, okay, you see here, B is common, and you have A plus A bar. And of course, okay, A plus A bar, you know, is the same as 1. So indirectly, I'm trying to tell you this is correct. Okay, my this expression here is correct. Okay, and I'm going to apply these expressions into here. So this is similar to our A. I take this one same as my A. Okay, this is the same as my B. Okay, of course, this is my A bar. So result you are going to obtain here is x4 plus x5. Okay, based on this. And once I got this x5 already, now, okay, you are going to say, let's say that this is the B, right? You say this is a B. Okay, step by step, we do it. Sorry, I'm a bit too fast. Back to red color, but I need to erase this one first. Okay, red color. Okay, now you find that this is a A. This one here is also my A bar. This whole thing. Okay, I call it as a C. All right, this one I call it as D. This is my A bar D. Okay, so with this, okay, if I consider this one, of course, this one can be C, can be D, and so on. So you find that, okay, the next step that I'm going to have here, it will be the same as I write the C. These two, I group them together. A plus A bar C. So result you're going to obtain will be A plus C. So A written already. C is X5 bar X6. All right. This one, A plus A bar D. So result you are going to obtain is A plus D. So this is the D. All right. Then you have your this one, and 7. Okay, from this one, move to here. So all these are just explanation only. Okay, next steps. Okay, so you are going to find that now I have done everything for this x4. I may consider now x5. Okay, this is my new A. This is my new A bar. Okay, new A bar. So this is my new B, new C. Okay, if you can see, okay, one shot you can do for all. So you find that I don't touch this one. This is my new A, new B. Okay, A plus A bar B. So A plus B. So A plus A bar C. So you write it as A plus C. C is this one. All right. So of course, okay, after this, okay, you find that one more steps, you're going to get your answer. All right. So of course, these two, I can further simplify based on the same concept. So you find that is 4, 5, 6, 7. Yeah, too fast. Okay, I forget about all the all functions. Right. Okay, plus 5 plus 6 plus 7. Okay, so this is the answer, okay, for my this priority encoder. And this priority encoder here is the lower number, okay, highest priority for this part. And of course, okay, you can see the everything over here typed out nicely for you. But this is how I explain, okay, for my Z2. We can do the same thing for Z1, okay? We go and first list down the expression first. All right, same thing for the Z0. We list out all the expression first. Then we apply the same concept, okay, to minimize it. And for this one here, maybe this one I can directly do from here. So for the case of Z1, you find that this is an expression that I am going to obtain. So my Z1 here, now these two are common. Okay, these two are common. So you find that, okay, it's a XO, X1. So I do these two first. Okay, then plus, of course, okay, later on I combine with this one. You find that, okay, everything is common until 2, 3, 4, 5. Okay, common, 1, 2, 3, 4, 5. Okay, so I got x6 plus my x6 bar x7. So of course, okay, when you see this, I apply the same concept. So you find that these parts here, just now is x2 plus x3. Now I must make sure that to show this one here, these two must be 0. And subsequently, these parts here, a bit lazy to write all this. Okay, 2, 3, 4, 5. And it is given here as a 6 plus your 7. So this is my simplest, okay, expressions already for implementing my Z1. So can apply the same thing for Z0. Okay. So do I need to show that? I don't think so, okay? Because it's a matter of, okay, be careful and show it, simplify it. All right, so you're going to find that this priority encoder here, I only show you the low number, high priority. The high number, high priority is in the in your tutorial. Okay, answer is there, final answer is there. So we will try it out in our tutorial rather than everything I do it. Okay, that ends this part here. I say, okay, very simple only. Okay, I stop presenting. So is there any questions? Okay, is there any question? If no question, I say that, okay, we are going to look at tutorial. Remember Monday that time? Okay, some of the tutorial are quite easy. So we can try to answer it. So anyone try the tutorial? So later on this one I remove because assignment not necessary to be there. Our second tutorial. Is there anything on multiplexer? Okay, I think this is the one that I do, right? Anyone try any questions? Anybody try anything? Why suddenly nobody want to say anything already? Okay, multiplexers here. Now we still have about 20 minutes. So can start trying, okay? Question 1, 2, 3, and 4. Everything? I think question number 4, I did the first part, right? The second part, I leave it to you. Okay, so can we, okay, try to do third question especially, 5 input variables. Okay, maybe we focus on these questions here. So in the test, okay, you have 5 variables, 5 input variables. So anyway, we don't care about the multiplexer first. We look at these expressions here. How am I going to determine, okay, what is the input to the multiplexer? Question now is, am I supposed to come up with a truth table? I leave it for discussions. Are we going to come up with a truth table for these particular questions here? I want this one. What do you think? T3. Okay, meanwhile, let me take some more thing. No, it's from here. I want the truth table. No, this one can, not too big. Now, class, what do you think? Okay, because okay, for me to sort of okay see the multiplexers input here, of course, I base on this function. And now this function here, because got 5 input variables, if I were to write out the truth table, it is actually can, but very time consuming. Okay, very time consuming. So in this case here, can we think of any other easier way, shorter way to solve this problem? Now you see, I already give you the hints already. I'm going to use Canumap. Okay, I'm going to use Canumap to show it. So of course, okay, I must make sure I show at the proper or fill in at the proper locations. So please help me in case, okay, I see the wrong one. So for this particular expressions here, I think I'm going to choose A as my this label here. So here I use A. I use A bar first. Okay, A over here. Okay, A bar A. So you're going to find that, of course, okay, over here, I will choose BC and the DE. So get ourselves familiar first, okay, where is the midterm location? So this is all 0, so I put right small one. So 0, 1, this significant, 2, 3, 4, 5, 6, 7. All right, so this one exactly the same as what we usually see. And now A is a 1, therefore 16 is here. Okay, so every one of these midterm location, I'm going to add 16 to it. Of course, 17 now, add. So this one, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 31. Okay, so these are all the midterm location for these color maps here, and we fill in this one, then only we answer the part A. Okay, so we use a different color. All right. So for this case, this one here, I don't really do looping. Later on, you are going to find that I don't do looping. So help me to confirm that I'm doing the right one now, because it's a bit difficult to see. So 0, 1, 2, okay, 6, 7, 9, 10, 15, 16, 18, 20, 21, 27, 30. Next, 3, 4. This one here, we are going to put it in here as don't care. Okay, don't care. So 3, 4, 11. Okay, 12 and 19. All right, so these are the way I fill in my color map. Of course, if you think, okay, the location for the midterm very kacau, right? Then what you can do, just erase it. Okay, you use pencil, you write, then you erase it. And make sure, remember, 7, 8 is here. This is 1, 1, this is 1, 0. All right, this is 1, 1, this is 1, 0. Okay, so after fill up this color map already, I try to answer this part. Determine the input, okay, to be applied to a 16 to 1 multiplexer to implement the following in part A. All right, using the variable ABCD as the control signal. Okay, so over here, I want to straight away do it. 16 to 1, 16 to 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I think I will do only a few. Ten, 11, 12, 13, 14, 15, 16. Okay, this is my input. Because you have a 16 input here, you will have 1, 2, 3, 4 selector line. So label properly. So in this case here, suka hati question never say, okay, which one to be used. So suka hati saya. All right, so what do you think? So we either choose A, B, C, D, or we choose B, C, D, E. All right, so let's see, okay, here later, we decide later. Now you see, okay, if I want to say there are equations here, if I choose A, B, C, D, then here you're going to have here is, of course, is the is it the highest? Yes. Okay, 0, 0, 0. With your E, okay, could appear here. Then you see here. Will it be easier? Because in this case here, okay, I am not, like I said earlier, okay, I'm not going to do looping. I'm just trying to combine, try to make use of this one to replace my truth table so that, okay, I can save some time. Instead of writing a lot of this 0 and 1, I make use of this Kano maps here so that I can get my answer fast. So you find that, okay, if I were to sort of combine these two together, see as you combine these two together, what you are having here is, okay, you have your A bar. Of course, everything is A bar. Then now you find that, okay, you have a B bar, you have a C bar, you have a D bar, and only E are different. One is E bar, the other one is E. Okay, and this is exactly the location that we are going to have for this one. So what should I put for this one here? Answer is 1, right? Because both output are 1. Next, this one here, for these two that I combine together, I'm actually, okay, talking about A bar, B bar, A bar, B bar. Then this one here is E, D, this is D. Wait, E bar, yep. This is D, this is D, A bar. Oh, I myself confused. Okay, so it's A, B bar, C bar. This is a D, and you got here is E bar plus E. All right, because your D is a 1 here. Okay, D is a 1 here. So this is trying to say that, okay, if this is the conditions here, this is exactly same as our 1. Okay, 0, 0, 0, 1. So bear in mind, this is representing A, B, C, D. Okay, D is a 1 over here. So I saw this. Okay, one is don't care, the other one is 1. So now is the time we can suka hati lah. What do you want this X here to be? Suka hati, I want it to be 0. Suka hati, I want it to be 1. If I put it as 1, of course, answer that you're going to put here will be a 1. But if I, okay, leave it as 0, okay, 0, then you find that the answer here will be E bar. So either one. Suka hati, So I consider these two. The third location you find that, okay, will be this one. C is a 1. So you find that 0, 0, 1, 0, isn't it? 8, 1, 0. Okay, 0, 0, 1, 0. So A is a 0, 0, 0, 1, 0. Okay, if I put here as A, B, C, D lah. I actually can put it as a B, C, D, E. Then I will have to see this way lor. From here, compare with this one. So there's more than one answer. So if I take it as a selector here as a B, C, D, E, I take this one, compare with this one. Same location, we compare. All right, and fill in the time, be careful. This one first, then only this one. Okay, clear to all? So 1 here, this part here, and this one here. Okay, this one here, you cannot really suka hati, because I'm taking here as a don't care. This is a 0, isn't it? So in this case here, definitely I'm going to put the answer here as 0 rather than, okay, say the answer here is E bar. Because no need to put in any power better. All right, so with this combination, we choose the input here as 0. Next combination, we put it as 1. Okay, for this one. Then this one here. Careful, this is the one that I'm going to do for this part. So you find out, okay, answer is E. This one can suka hati. Either answer is E bar or 1. Yeah, exactly the same as this. Okay, either is E bar or 1 for this case. This one here, don't care, and this is a 0, same condition, answer definitely 0. All right, definitely I'm going to take 0. This one here, answer is E. Okay to all? Okay to all? Anyone got any question to ask about this part?